Hello, my name is Syed Nezhadi, and this is my presentation about the final project of Big Data Analytics course in Harvard Extension School, and my topic is MongoDB. What is MongoDB? MongoDB is a very popular open source document-based database management system, and is one of the leading NoSQL databases in the market. It is equipped with lots of features, including supporting JSON as a document and having very rich document-based queries that you can do a lot. You can aggregate, you can search, and so on. It supports replication and high availability and auto sharding for distributed databases, supports full index, and has a flexible aggregation and data processing module. It has fast in-place updates and it supports atomicity at document level. It doesn't have the full atomicity like a traditional database server, but at the document level, yes. And it is good for distributed storage. Why so popular? Although it is a distributed database management system, but in my opinion, the reasons are the following. One is being a document-oriented database. With the increasing number of applications who deal with the semi-structured data or unstructured data in large, like social media posts, this kind of databases are very popular these days. It supports JavaScript and JSON, and that is a big plus because, especially for the web developers, because they learn it very fast, and it can get integrated with the other popular server-side and client-side technology very well. Although it is an open source product, but it has a professional support and a commercial company back up this product, and it has an active and large community. There are many use cases for MongoDB. Anything that deals with not unstructured data in large, including high volume data feeds the data is generated by machine or financial security, social medias, operational intelligence like social media monitoring, ad targeting, and real-time dashboards, and of course metadata because of the nature of it. Including product catalog, data analysis, biometrics, and content management, news sites, multi-device rendering, sharding, and many more applications dealing with semi-structured and large data. The goal of this project is to evaluate how easy to use MongoDB for storing and querying semi-structured data and integrating with other popular technology, and how fast is to learn MongoDB. I decided to use MongoDB to develop a green button application. Green button is a recent initiative in North America that started from White House that gives utility customer easy access to their electricity usage data. You can actually go to your utility company's website and download your data by hour or daily. It is a very hot thing in the IT market nowadays, and recently there were some contests in US and here in Canada. The data file that comes from these companies is moderately complex XML files that is not easy to deal with. So here I wanted to use MongoDB to deal with those kind of data, and my objective was to develop a full stack but simple application to analyze green button data of a household, in fact my own home, and provide analytical and useful graphs visualization. Here is a sample file format, the diagram that shows that for Ontario, Canada, and you can see there are different levels of tags, and inside each them there are information. So it's moderately complex file that is not easy to deal with, especially if you want to implement it in a in a relational database would be tedious. I decided to, beside dealing with the complexity of data, evaluate the integration of MongoDB with other popular technologies in different layers of a web application. And I try to choose the most popular ones in the market nowadays. And that's why I selected Node.js for the application layer, and the for presentation layer is HTML5 and D3.js. On top of those, I use some lightweight modules, like for example Mongo.js I use for connecting to MongoDB from Node.js, and Node static is to delivering the static files like HTML, images, CSS, JavaScript files to the browser. And I use the NVD3, that is a lightweight library on top of D3.js for creating reusable graphs. To be able to import the XML file to MongoDB, I had to change it to JSON, and for that I used very simple generic tool that just changes the text, XML text to JSON symbols, and convert the data to JSON and import it to MongoDB using import tools of its own. Here it shows the data flow in these applications. The application has three layers: data layer, application layer, and the presentation layer. And because all of them are using the JavaScript language and JSON, and this data flow is very seamless, and it was actually very easy. My server that is written in Node.js sends the queries to database in JSON, which is the way that the MongoDB works, and receives the data in JSON. And I'll send those data back to the web client, which is D3.js and NVD3, that they also use JSON for defining the graphs. And this is in the response to a request that the web client sends through AJAX. At the beginning, there is an initial request that comes to the server for static files. Actually, there is only one HTML file, the small HTML file called chart.html that I used, and very small script in Node.js that does the whole application. Here we can see the output of this application in the web browser. Is actually very simple. There is a menu at the left side with 4 items that they are the kind of graphs that I thought would be important, like electricity consumption by month, electricity cost by month, consumption statistics like minimum, average, maximum by hour of the day. And one of the interesting one is the consumption versus temperature plot, if there is any correlation. And on the right side, it shows the graph that is using NVD3 and D3.js. In the next 3 slides, I'm going to show you the graphs that I have in the system, and only a part of the code that the query sent to MongoDB, and see how easy that is. So here I have the electricity consumption by month, and the query that I used here is just sending one simple query to MongoDB, and I got the data and then send it to the web browser. Here I have the electricity consumption by hour of the day. You can see I have the minimum, average, and maximum amount here. And it, as expected, it shows actually in the middle of night when we're sleeping, it has the lowest consumption, but during the evening is the highest consumptions. And if you look at the query, I use some aggregate function of MongoDB that I aggregated by hour of the day, and it gives me average and maximum and minimum, and very simple query. The last one is the consumption versus temperature scatter plot. Here it's a very interesting graph because actually it shows until the temperature is around 15 to 17, 18 centigrade. We use metric here in Canada. Basically the consumption is kind of steady, but as soon as it goes higher than 18 degree, it has a strong linear correlation between temperature and consumption, and that's due perhaps to the air conditioning. And again, the query is very simple to get all these values. I have got the average of the temperature and consumption by the day of the year, but then I just plot between the average temperature and average the consumption. Okay, I didn't want to go to the details because everything is written in the report. Just want to share my experience with MongoDB. It was actually a good experience, and I was surprised at how intuitive and easy it was to install and use MongoDB. And learning it was easy, especially for me that I had some experience with JavaScript in the past. Dealing with the green button data was also easy after I imported the JSON file. It was easy to and very quick to clean and extract the data I needed. I don't think that was possible with the relational databases. Another positive thing was the integration, seamless integration with the Node.js. I used Mongo.js for that, and writing statements there was like writing in MongoDB's own console. Sending data to the D3.js through JSON was also very natural and seamless. And at the end, I was able to develop a full stack application, but simple one that actually looks good with only a few lines of code. And that's thanks to the popularity of MongoDB, because every question I had, I could find it immediately in internet. Here I want to talk about lessons learned. Although my experience with MongoDB was very smooth and I didn't have many challenges to learn from, except that I learned MongoDB is very easy and useful to use, and hopefully in future I'm going to use it. But one thing I learned is that I always thought that when you use a document-oriented database, you normally deal with unstructured data, so you work on the original dirty data. But dealing with the green button files, after a while I realized if I want to make the queries on the original structure in JSON, it's not that easy. So even in this kind of databases, it's better to first transform the data to a more structured data to be able to use it. And that's what I did. I extracted and transferred the original data to a very clean collection of the fields that I really need them. But I used MongoDB scripts that are very easy to do that. I hope this presentation was helpful for many of you, and you can also start using MongoDB or projects. Good luck.